Okay, let's just get straight to it. What if I told you that the topics we're about to cover could make up a massive 20% of your entire higher tier GCSE maths exam? Yep. Getting your head around this stuff is, without a doubt, one of the fastest ways to give your grade a serious boost.
So today, we're diving into a super fast revision session on ratio, proportion, and rates of change. We are going to cover the whole shebang, from the absolute basics all the way up to those tricky questions designed to catch you out at the higher tier. So here's the game plan. We'll kick things off with the fundamentals, ratios and fractions. Then we'll build on that with proportion and scale. After that, we'll see how it all works in the real world with percentages and units before we tackle the big one, rates of change, which is where those top grades are won.
Right, let's get into it with section 1. Honestly, getting these building blocks solid is absolutely crucial for everything else that's coming up. So what even is a ratio? Well, it's just a simple way of comparing things. Think about making squash. If the ratio of squash to water is 1 to 4, it means for every 1 part of squash, you need 4 parts of water. But here's the thing you absolutely have to remember. The order is everything. A ratio of 1 to 4 is a nice drink. A ratio of 4 to 1, well, that's basically just squash. They are not the same.
Now, a classic question you're guaranteed to see is sharing an amount in a given ratio. So let's say we need to share £60 in the ratio 2:3. How do we do it? Just follow these steps. First, add the parts of the ratio together. So 2 plus 3, that gives us 5 total parts. Simple. Step 2, you take the total amount, 60 quid, and divide it by the total number of parts. 60 divided by 5 tells you that 1 part is worth £12. For step 3, you just multiply that £12 value by each number in the ratio. So 2 parts is 2 times 12, which is £24, and 3 parts is 3 times 12, £36. And you should always do a final check. Does 24 plus 36 get you back to the original 60? Yes, it does. Boom, done. And here's where it all starts to connect. That 2-3 ratio also means one person gets 2/5 of the money and the other gets 3/5. See? Ratios are just fractions in disguise. This relationship is what we call direct proportion, and if you were to plot it on a graph, you'd get a perfect straight line going right through the origin. Okay, let's keep that momentum going. Now, we'll see how this leads perfectly into our next section, proportion and scale. This is all about getting how different quantities are linked and how they change together.
Right, this slide is a big one. You have to know the difference between these two. Direct proportion is pretty straightforward. As one thing goes up, the other goes up at the same rate. You work more hours, you get more pay. Simple. Inverse proportion, on the other hand, is a trade-off. As one thing goes up, the other comes down. You get more people to paint a fence, the time it takes goes down. And just look at their graphs, totally different shapes. Now, solving these with algebra is a major higher tier skill, so let's break it down. Imagine it takes 3 people 8 hours to do a job. How long would it take 4 people? Okay, step 1, write the relationship. Time, let's call it t, is inversely proportional to the number of people, p. So t is proportional to 1 over p. Step 2, we turn that into an actual equation. T equals k over p. K is just a constant number we need to figure out. For step 3, we use the numbers they gave us. We know that 8 hours equals k divided by 3 people. A little bit of rearranging and you find that k must be 24. Now the final step, we have our finished equation. T equals 24 over p. We want the time for 4 people, so t equals 24 divided by 4, which is 6 hours. See, not so bad when you have a system. Okay, listen up, because this is a huge deal and an easy place to pick up marks. If you're scaling up a 3D shape and the length scale factor is, say, k, let's call it 3. The area scale factor isn't 3, no way. It's k squared, so 3 squared, which is 9. And the volume scale factor is k cubed, 3 cubed, which is 27. You have to remember this. Length is k, area is k squared, volume is k cubed. Drill that into your memory. Right, on to section 3. This is where we start applying all these concepts to the kind of real-world maths problems that you will definitely 100% find in your exam. Ah, the reverse percentage problem. This question is a classic trap, and it catches so many people out. The most common mistake is to find 20% of £80 and just add it on. But that's completely wrong. Why? Because that 20% discount was taken from the original price, the one we don't know, not the new sale price. So here's how you nail it every single time. If a coat has 20% off, that means you're paying 80% of the original price. So that £80 you paid, well, that is 80%. Makes sense, right? So to find what 1% is, we just divide the £80 by 80. That gives us £1. And if 1% is worth £1, then the original 100% must have been £100. It's that simple when you think about it that way. Okay, compound units. They're everywhere. But here's the secret. The unit itself tells you the formula. Speed is in miles per hour. That literally means miles divided by hours. Density is in grams per centimeter cubed. That's mass divided by volume. Pressure is newtons per meter squared. So that's force divided by area. If you know these three, you're golden.
And here we go, the final section. This is the big one for you higher tier students. This is where you can really flex your maths muscles and bag those top grade marks. Let's be crystal clear about one thing. On a graph, gradient is the rate of change. They're the same thing. Think about a distance time graph. The gradient is the change in distance divided by the change in time. Well, what's that? It's the formula for speed. So the gradient of a distance time graph is the speed. A steeper line means a bigger gradient, which just means a faster speed. It's all connected.
But what about on a curve? On a curve, the steepness is always changing. So if the exam asks you for the average rate of change between 2 points, you draw a straight line, a chord, connecting them, and find the gradient of that line. But if it asks for the rate of change at one exact instant, you have to draw a tangent. That's a straight line that just kisses the curve at that one single point. Then you find the gradient of that tangent.
Finally, let's talk growth and decay. It sounds complicated, but really it's just doing a percentage change over and over again. For growth, like a bank account with 3% interest, you're multiplying by 1.03 each year. For decay, like a car losing 15% of its value, you're multiplying by what's left, which is 0.85. And that little n in the formula, that's just the number of times you do it, usually years. Just plug the numbers into the formula, and you're good to go. Okay, let's do a super quick recap of the absolute must-knows. 1. Ratios are all about order. 2. Direct and inverse proportion are opposites. One goes up together, the other is a trade-off. 3. For reverse percentages, figure out what percentage you actually have before you do anything else. And 4, gradient is rate of change. And for a curve, a tangent gives you the rate at one specific moment. So there you have it, a massive, massive topic, all broken down. But look, just watching this is only half the job. The real progress, the thing that will get you the marks, is practice. So take a look at the screen, pick one of these areas, whichever one you feel least confident about, find a past paper question on it, and give it a shot. Right now, while it's all fresh in your mind, you've got this. Good luck.